It's recording exponent laws. The first one is if some variable x raised by m, that means powered by m. You understand powered by m?
Yeah.
That means you multiply x m many times. Now x raised by n, that means you multiply x n many times. If the sign is multiplication there, sometimes they just put a dot. That means
Yeah.
multiplication. In that case, you add up the powers. For example, 7 raised by, let me say, call it 2, and multiplied by 7 raised by 1. Now,
7 raised by 3.
yes. Or simply you can reduce it. Now, simplify that. You see? That's the same thing.
Oh, yeah.
Right? So that rule is valid for all kind of x values and all m real numbers. And most of the times m is going to be a rational number. So they will not give you an irrational number. So most of the time they are going to be a whole number, like 2, minus 3, those kind of numbers. Do you know what are the negative powers?
Yeah, so when it's negative, to make it positive, you have to put the
Right.
number on the bottom under 1.
That's
and
right.
then it makes it positive.
So you do the reciprocal of that, right? For
Yes,
example,
reciprocal, that's what it
3 powered by minus 1.
equals 1 over 3, and 3 to the power of 1, which is just that.
Yes, that's right. Now, do you know why do we do that? What is the reason behind it? Why it flips?
No. I just know that it flips.
All right, let me explain you the reason. So, the reason is pretty simple. Now, 1 over 3. Now, can I write it like 3 raised by 0 divided by 3?
Yeah, because 3 raised by 0 is equal to 1.
Very good. Now, the next thing is we use another property, and that property is if you have division between these two terms, then you're going to subtract them. You subtract this one from that one. So we use that property since you have the same bases. So you subtract the powers. So we subtract this power from that one.
Oh, I see.
Good.
Yeah, so then it's 3 minus 1.
That minus 1. That's simple, right? So any number raised by negative power is going to get flipped like that. So that is the reason behind it. Now, those are two properties that we will be using in future. And they're pretty straightforward. And then if you have some x number powered by some power m and bracket another power, so in that case you do multiply the powers. And we can take one example: 2 powered by 3 powered by 2.
It's going to be 2 to the power of 6.
Yep, that's right. In order to elaborate it, now if you don't want to do that, you can do 2 times 2 times 2 and then powered by 2. That means you write this bracket too many times. And in the bracket we have 3 numbers. You multiply the whole bracket with itself. And how many 2's we are getting there? 6.
Right? Oh, yeah, I see that.
Yeah, so we have 1, 2, 3, 6. So we proved that if you solve that, still you get the same thing. So rather doing this way, we will be just simply multiplying the powers, because there's more work doing that way, right?
Yeah.
So that's the power rule, and the reciprocal, you already know that, right?
Yeah, the rest is pretty much the same stuff.
So let me write it down. Negative m. Is it n or m?
Where? That?
Yeah.
N, but it doesn't really matter.
Alright, if that's m, we'll be writing 1 over x raised by m. Uh, which problem would you like to do?
Well, those ones are all just like part of the lesson.
Okay,
But I have some like from homework and stuff
cool.
that I didn't get.
Let's try them. Zoom it. Okay,
So it's
x.
xy to the power of n
Okay,
over
over
bracket xy
xy
bracket
2n,
yes, and that's all in brackets as well, and 2n again.
2n. Cool.
And then for this one, you're supposed to put these in. For
Right. We have to evaluate them for those values and express answer in a rational form. Now, before substituting the x values, so what are those x values? Negative 2?
Yeah, y is 3, and n is negative 1.
N is negative 1. Alright. Now, there are two ways of doing it. One is you substitute all those values right away there, and then you simplify it. And the second way is you just play with them and simplify the whole expression. When it becomes really small, then substitute them.
Okay.
So yeah, we are learning the simplification. Let's do it other way around. So we do simplification and then we substitute the values. So what would you do in this case?
So this one's already fine, but down here,
Good.
you have to multiply x by 2n and y by 2n.
Powered, you mean, right?
Yeah, yeah.
X powered by
Yeah,
powered
x power
2n.
and y power 2n.
Good.
And then they're still all in the back brackets.
Cool. Now the next thing.
Next thing, I guess you can. Would you bring that in now?
Not yet, because
Okay, you can divide now then.
you can subtract the. We're gonna use that rule. This one.
Yeah, right.
Yeah.
When you're dividing, you're subtracting the exponents.
That's right.
Yes.
And we have x and x. The
Yeah,
basis.
So it's 1 minus 2n.
Very good. And y.
N minus 2n.
Big bracket 2n. Now the next step. We don't have to do anything with that.
Yeah.
1 minus 2n. And
N minus 2n, so just n. Negative.
Negative
yeah,
n.
negative n. Yeah.
Good. Now we distribute the whole power. So this power is gonna multiply with the powers because we know that powers multiply.
Mm-hmm.
When you have a power there, it goes in and multiply with the other power. So I don't know what's. Let me choose that one. So we simply do 2n bracket 1 minus 2n. Then we do y 2n bracket negative n. So we got 2n minus 4n squared and then negative 2n squared.
Mm-hmm.
Now you're going to substitute all the values that we have there. Let me see if that's in a tablet mode. Okay. So the values that we have are negative 2, 3, and negative 1.
Yes.
X is negative 2 and
Negative 2, 2, bracket is
1.
negative 1. Yeah.
And is negative 1? Yeah.
Yes.
Then minus 4, negative 1 squared.
Mm-hmm.
And
Times-
y is 3.
Yes.
Negative 2, negative 1 squared.
Yeah.
So let's do it here. Negative 2.
Yeah, negative 2 and negative 2 again. And then over there.
That's positive 1.
That's going to be
right?
positive 1
Yes.
minus 4.
Negative 6.
Yes.
Good.
And times, so positive 1,
Mhm.
negative 2. So 3 to the power of negative 2.
Cool. Right now you can expand them. Negative 2. The power is negative, so it's gonna flip it. and power becomes positive now. And same thing there. Now we times -2 even many times, so it's going to
Yeah.
be a positive value, right?
Yeah.
-2, -2, -2.
And 6 times.
Yeah, 6 many times, so it's going to be positive 64.
Okay.
Right.
And then so it's 1 over
Yeah.
64 times 1
Yeah.
over 9.
Now, if you have calculator, you can do that, but I did in my head, so 576, 1 over 567. So yeah, that's gonna be your answer, and you're gonna get the same answer by direct substitution. Rather expanding
Yeah.
it, if you do the substitution,
This
so
might take longer.
it's not gonna, probably it's gonna take less time, but since we are learning those operations, so show them that you know how to simplify the things, and then you substitute.
Okay.
So because we are learning the exponent operations, right?
Yeah.
So we have to know how to use them. So yeah, let me show you a few. I think you know how to direct substitute, like
Yeah.
-2, then y powered. So, and probably it's gonna be more easier. They didn't say like which method you have to do evaluate.
That's what I was
Yeah, that's what they're asking for. And the rational form means fractional form. That's the rational form of that. So we did that one. Next.
Next.
I'll go to the next page.
Let's do 18F. So it's just simplify, but it's so
3x4.
yeah. Actually, let's do E. Let's do E first.
All right, let's do E. What is that?
Bracket a to the power of 10 minus p. Bracket 1 over a to the power of p. Let's just simplify.
Just simplify. All right. And that's 18. Good.
Yes, that's L.
All right, now that's A and that's P. So we see that we have the common base, but that is in a fraction form. So the first step is you bring A on the top. So if
So it's over 1, so then it's just a.
yes, if I flip it, the power is gonna become negative,
Oh yeah.
right? Because 1 over A is equals to A powered by -1. So if you want, I can do it in 2 steps. Let me do step by step. So 1 over A means -1 raised by P, and we have a bracket A.
Okay, so and now you just expand it. Well, first you have to apply p in.
Right, so we multiply them, -P. What's happening there? A -P bracket. And you can use small tiny bracket there because we will, though it's not going to change anything, we add the powers now. So we get -P plus -P. Right?
Yeah.
You're adding them. So
10
A,
minus 2p.
right. And if you want, we can do the factors. You write 2 and then 5 minus P.
Okay, I see. Yeah, let's do it in 18 then. That's just a bit more. Messy.
F, you mean?
Yeah, it's
All
right.
right. All right, let's do F. We do it there. Number 18.
It's the same
F.
concept. That's want to make sure.
Yeah. So we have 3x4 bracket 6.
Minus m, and then 1 over x in brackets with
That's a
m.
multiplication, right? So
Yeah.
we make a bracket 1 over x powered by m. Right.
So with this one, it's going to be the same. Well, first we have to put 6 minus m into there, right? So
Right.
it's going to be multiplying.
3 is in the bracket, yeah, so you have to distribute it.
Yeah. And
So
3 will get like
6 minus m.
yeah, and x.
X 4 multiplied by
So 24 minus 4m.
4 times pi. Yeah, that's right. We will.
Yeah.
Now we do the same thing. Flip it.
Yeah.
Not negative, but x power negative 1. And m there. So we got 3 6 minus m, and x 24 minus 4m, and then we have x negative m.
And now
Base is same, so
we can multiply it, or in this case, you're adding the exponents.
right. We add.
So it's going to be, so it's 24 minus 5m.
Right. So I don't know if they want. Yeah, because we don't have m, so we have to write it as it is. And yeah, it's gonna stay as it is. 24 minus
5. And that's the final answer. Yeah.
Right, that's the simplification of that. Yeah, we have to simplify. That's it.
Get some other stuff.
Do you understand, Ben? What's the relation of the radicals and exponent?
Yeah, because like, for example, x squared is also equal to the square root of x.
No. X powered by 1/2.
sorry.
Yes. So basically, square root of any number, let's say 7. That means 7. Now the third right there is 2, and people don't write it, so it's acceptable. But if that is a cube root, they must mention it there.
So anything over 2.
For example, cube root of 5. So you're gonna do cube root of. You're gonna write in exponent form. So you will be writing 5 raised by 1/3, and in the same manner, square root of, let's say, x, you will be doing x powered by 1/2. And how it works, I can show you with one example. For example, cube root of 8. Now, according to the definition, cube root of 8 is gonna be, it's equals to that. Now we solve that thing. 8, we can write it as a power of 2. 2 powered by 3 is gonna be 8. 2 times 2 times 2 is 8. And now we use the property. We multiply the powers. You see the power that we were using, like the properties.
Oh yeah, we multiply it like that. So it's 1/3 times 3, which is just 1.
So the answer is. So the answer is 2.
3 the root. So that is equal to 2. I see.
Yes, cube root of 8 is 2, because cube of 2 is 8. Cube of 2 means that 2 times 2 times 2, right? Because when you multiply 2 3 many times, you get 8. Therefore, cube root of 8 is going to be 2, and that's the more kind of justified way of proving it. In the same manner, square root of 16.
4.
Yeah, that's just 4. And if you want to do it exponent way, we're gonna write it like we convert it to the exponential form, and then we write 4 squared, and now you multiply the powers.
4 1.
Which is just 4.
Yeah.
So those were a couple examples. Now next thing we will do a couple of questions. We already did that one, right?
Yeah.
So they didn't explain the reason, but I explained to you how to do it as a layman. So these
I'll
things.
go into some of the homework ones that I didn't get.
Good.
Let's see. So 6E, page 229.
229.
So it's 16 in brackets, 16 to the power of negative 2.5.
2.5.
Yeah.
Bracket.
To the power of negative 0.2. Divided by 16 to the power of 3/4.
Good. Alright, so the first thing that I'm gonna do, I multiply the powers. Right. So this power is gonna multiply by that power. So we do 16, negative 2.5, and another bracket, negative 0.2. Now, there are two ways of doing it. You can convert them into the fractions.
Mm-hmm.
Now we know that 2.5, like $2.50, is basically half of 5.
Mm-hmm. Yeah, so 5/2.
And 20 cents, 0.20 or zero point 0.2 is 20 cents, is
1/5 of a dollar. Yeah.
get 1/5.
So it's like multiplying those together.
Right, so we multiply negative 5/2 with
1/5.
1/5. That's negative, right?
Yeah, it's negative.
Okay. So
You
negative,
get
negative.
It'll end up being negative half.
Negative, negative turns into positive, so
Yeah.
we got 16 powered by 1/2.
Yes.
Good. And now,
And now to subtract these, you have to put them into common denominators, right?
right,
So
we
you multiply that by 2 to get 4.
yeah. So we have a division, base is same. Whenever your base is same, we always subtract the powers. And now you times it by 2 over 4. 2 minus 3 is gonna be
Negative 1 over 4.
good. In what form do they want your answer?
Um,
Rational form means something which looks like P divided by Q, like 7 over 8, something like
with
that.
no powers involved.
Mm-hmm.
So what he was having us do is put it like back into that form, and
Right.
then like do it from there. So that would be like
Let me teach you another easy way. So what
Okay.
we do, as we learned right there, I know square root of 16 means that, so we already have exponent form, and I know that if you raised, my motive is to get rid of this guy 4.
Mhm.
In order to do that, we find out a number whose power is gonna be 16, and that is 2. So I replace 16 by that power, 2 power 4.
Mhm.
Now the powers multiply.
Yeah. So that's gonna be 1, and it's just 2. Or yeah,
Yes,
1/2.
1/2. Because 4 times the negative 1/4 is gonna be negative 1, so answer is that. So that way is gonna be more easier, and if you don't want to do it that way, then the another alternative way is you flip it and you get 16 powered by 1/4, and then you do square root of 16 and then 1 over 2, or you do the fourth root right away.
Oh yeah.
And fourth root means which number powered by 4 is 16. Again, you have to think about the same thing, right? So rather doing this way, you use that concept right away there.
Okay, I see.
That's more easy, right?
Mhm.
So I did that one.
All right, let's find another one. Let's do.
Right, so 1.6, so what we do, one point six is 16 divided by 10,
Mhm.
and 16 over 10, if you simplify that, you will get 8 over 5. So you divide numerator and denominator for the same.
Yeah.
So we got 8 over 5. And now the next thing, the power that we have right there, let me do it in 2 steps. You will understand it better. So I write 1 over 5. 5 looks weird. And then whole thing powered by 8.
Okay.
So why do I do that? Because I have to find some number whose power 5 is gonna give you a negative. Now the power is odd number, so obviously any negative number is gonna give you a negative number out. So now you have to use calculator to evaluate which number's power 5 is gonna be that. So do you have calculator there?
I do.
Okay. So last number is 6, so let me do 6 powered by 5. Yep, here we go. So we got it. When you do 6 powered by 5, you get that number. So we simply write negative 6 powered by 5. It's important. Bracket is really important because of the negative sign. Powered by 5 is going to give you that thing, and we have a bracket 1 over 5, and then another power 8. Now that is 1.
Yep.
So negative 6 raised by 8, that's going to be the answer.
Yeah, 1,679,616.
There's no decimal?
Nope.
Okay.
So, how did you know that 6 to the power of 5 is 7,776?
I look at the last digit, and that is 6, and we know that 6 power 1 is 6. 6 times by powered by 2 is still 6, and 6 powered by cube is still 6. So every time we
so
power
always
it,
end in a 6.
yeah, so that there's a kind of common sense, or if you really don't know, then start by, like, we know that 2 power 6 cannot be, that big number. So start from 4 or 5 and then keep checking it. And most of the time, the answer is going to be within 3 to 8. And you check it, and it's going to take not more than 1 minute. Once you have that number which gives you that, write it down here. And ultimate motive is to cancel the fraction right there. That's
And
the
so
motive.
up here, so when you took out, you separate 8/5 into 1/5 and 8, will that work with any scenario?
Yeah, most of the time it's gonna work. Most of the time, this is the way. The way that I'm doing is a standard way, so it should work most of the time.
Okay, cool. All right.
Let's do another one.
Let's do just a side one. Let's do.
So, in order to prove this equality or identity, right? They are identical. That's what we call them. We solve one of the side. So now we know that this is that's more longer. So we start solving it. The first step is, now we don't have any powers there. I mean, there or here. So we simply write them without the brackets.
Okay.
And then we distribute that power. We multiply 6 with both of the powers.
Give me 6 over y. Yeah.
Good.
So it's going to be x, so half. Or, sorry, 2 over x and
Yeah.
2 over y.
Because 6 divided by 3 is 2. So
Yeah.
that is same as right side, so that is true. So this identity is valid. It
Alright.
holds.
Let's get a similar one, because I had trouble with this question for some reason. C. So I think I know how to do C. Just looking at it, for some reason I didn't when I did it.
That one?
Yeah, for this one, would you just since the exponent for them is negative,
Mm-hmm.
you have to flip them over.
Now that's a mistake that most of the students are gonna do. What they will do, we have to prove that this is same as a plus b,
Yeah.
number C14.
Yeah.
So what they're gonna do, students, they do that thing and they say, oh, it's true, but that's not right, because the negative power is for the whole thing. If there is a multiplication, you can do that, but we have a plus sign, so that's not valid. So if I give you a counter example, then we are done with the inequality. We can say that this is not true.
So that's as far as it goes. You
Yeah,
just can't.
let me give you some values. I call A is 1, B is 1, and by substituting them, you will get, yeah, you will get 1 plus 1, right?
Mm-hmm.
Actually, that's, yeah, let's try that one. And 1 plus 1 is 2, right? Clearly they're not, because we
Oh, yeah.
we got 2 powered by negative 1, and on the right hand side we have 2, which is not equal, so not equals to 2.
Okay.
So we have one instance, we have one example which is proving it that they are not holding the equality, so it's false. So
Okay.
proven false, sometimes it's more trickier than the equality, like proving that they are equal. So when you have these kind of relations, now this negative 1, you cannot foil it until that's the multiplication.
Okay. So if it's like if there's anything adding in the brackets, you're supposed to add them first, but you can't add that obviously.
Yeah, we cannot add them. One more example, for example, A plus B, you see that power,
It just stays like that because you can't add A and B.
yeah, that's not true, because when you
Okay.
foil it, you're gonna get 2AB in the end.
Okay, that helps.
Yeah, so since that is not equal, we have another term in the same manner. We cannot distribute the power.
Okay. Let's see. Let's do one more from that 14.
Okay.
So that's the same thing. Alright, let's do A. So it's 9 to the power of half plus 4 to the power of a half.
14A. 9 multiplied by 4.
Plus 4.
Oh, that one, right?
Yeah. Oh yeah, sorry, it's this one.
Okay, so power 1 over 2. What do you think about it?
So first when you so these are both so that would be it's equal to 3, right? And that's equal to 2.
Good. That's right.
And which equals 5, which is not equal to that. Because you can't
9 plus 4 is going to be 11, right?
Oh, that's true.
Okay, you mean that side? Yes, that's 5.
Yeah.
The left hand side is 5. But the right hand side is square root of 11, which is going to be 3 point something.
Yeah, so it's not a rational number.
That's right. That is an irrational number. So square root of some prime number, we call it irrational number. And not only prime numbers, even square root of like 6. Now we don't have the exact answer for that, so we call it irrational number. Why do we call it irrational, by the way?
Because you won't get a whole number from the square root. It would be like a bunch of decimals that go on forever.
That's true, and the most important thing, they don't repeat. There's no behavior in that. For example, if I do 1/3, I have a pattern. We have a decimal, but I have a pattern which is 3, 3, 3, 3, 3.
Forever.
Yeah, but in there, for example, square root of 2 is gonna be 2.1414, 2.14142. I mean, it's gonna be random numbers, and there's no repetition.
There's no pattern or anything.
There's no pattern. There's no recurring. So the numbers which doesn't recur, we call them not a good numbers. So irrational. Uh, s- so yeah, they're not equal. So
All right, perfect.
not true.
I'll get one from today's homework then.
Hmm.
There, right?
Yes, we can foil that thing. So -2 goes in here, so you get 32. Let me write here. 32 powered by -2. Or simply you can flip the whole thing down.
Why would you?
Because -2 is gonna flip this whole thing. Negative
Oh
power.
yeah, so you can do that
Yeah.
first if you wanted to.
Yeah, we can do that, and let's do that. So the 32x5 is gonna go down there, and -2 becomes +2. And in the same manner, we have -10 at the bottom. It goes on the top and becomes +10.
Oh yeah, I see. Cause yeah. And times 0.2.
Right?
Yeah.
-10 becomes plus.
Mm-hmm.
So after flipping them, now we
That's gonna be 32 to the power. Well, on the bottom, it's 32 to the power of 2 and x to the power of 10.
right.
Okay.
So
Now could you minus these guys? Or like,
yes, we can do that, and simply, or you can cancel them like that, right?
oh, because they're the same number.
The same.
So it's just 32 to the power of 2
Yeah,
to the power of.
yes. So ultimately, we got 32 power 2, and this power multiplied by that power,
Um,
right? You distribute it.
yeah, I know you distribute it. It's
Yeah.
1/5. So it's gonna be 2/5.
Yeah, 2/10 is 1/5, so 2/5, that's right. So when you multiply them, you will get 2/5. And now I have to get rid of this 5, and we know that 32 is 2 powered by 5. So I replace 32 by 2 powered by 5, and I have a, right? 32 is 2 powered by 5, and 5 powered by 2/5. Now when you multiply them, 5s are gonna cancel out. They canceled out, and we have 2. Right?
Okay, so it's just the answer is 1/2.
1/2 powered by 2. 1/2 powered by 2 is 1/4.
Okay. I see.
So that's the rational expression. That's the answer for that.
A few more minutes. So
Sure. We'll do. So all these notes are gonna be shared with you right away. So whatever we write in future, this is gonna be up later on. That's the OneDrive. That's the name of.
Yeah.
So yeah, do you have OneDrive?
Yeah. Well, I think once you get like a Google account,
Yes.
it's the whole account for everything.
I think yeah, it's attached with that. If you don't have account, probably you have to open OneDrive account, and then it's gonna show you the documents. Right. So that was that. Next slide.
What's
So the first step is we simply simplify all those things. Now since you have a negative power there, this negative power is going to flip this whole thing.
so you can flip that on the top.
Good. And on the top, let's do the top first. So 10 raised by 2.
And x raised by 6.
6. And then this whole bracket goes on the top. And -1 becomes +1. You don't have to write it because it's not going to change anything. And then you have a cube root of the whole thing. So
And so when that comes on the top, this one doesn't have to switch to the bottom. It just stays there.
because we don't have a negative power.
Okay.
That's a positive, so it stays there. So only in order to make negative power positive, we flip. Let's assume that's -2. Then you're gonna bring it down
Okay.
and make -2 + 2. Now the next step is you do add the powers of them.
It's going to be 10 to the power of 3 and then x to the power of 12.
Good. And the cube root of this whole thing.
Mm-hmm.
Now we know that cube root means we convert the radical form to the exponent, so this cube root becomes 1/3, power 1/3. And now we simply distribute the powers, distribute that power,
So it's going to be 10, 1,
and x root 12.
12 times the third.
Yes.
It's going to be, 10 to the power of 1, which is 10, and x 4.
4. So we got 10x4. That's the answer.
Perfect. Alrighty.
Any other question? Like, have a look at.
Most of them are pretty similar, it looks like. Why don't we just do...
So YouTube channel is London Math Solutions,
Okay.
and I'll upload it there.